I'm sure by now you would have seen the vertical takeoff and landing fixed wing at our exhibition stand, the Ulti-Transition. That's a shot of its ground control station. And the next generation of that model is going to be that giant there with a 6-meter wingspan, 24-hour endurance, and a 7-kilogram payload. Also on display is the DJI Matrice 200, or the 210 in this case. There's a couple of them, quite a common drone for industrial applications, and there's a good reason for that. And our other set of solutions or portfolio of solutions that we do is a full suite of ADS-B transponders. So I'm not going to go into the nitty-gritty or the principles or the processes of industrial applications. What I thought I'd do is I'd take you through two specific applications that we were involved with, and I'm going to show you, discuss it as a case study and show you actual footage and give you some reasoning behind that. So we're going to look at building facade inspection, and then Gareth also touched on that with one of his applications, which is spontaneous combustion detection. So the building facade inspection was quite an interesting project that came up. We actually went to go see a construction consulting company, and they had a client that needed to do the inspection of all the facades of a building so that they could go back, identify flaws in the facade, and be able to give a quote to go back and repair it. I originally went to go see them to sell them Pix4D, because we're a reseller of Pix4D. And out of the blue, the question came up and said, this is what our challenge is, can you help us with this? So because I am solution-centric, I immediately looked at the opportunity. We'd never been done it before, and there was very little reference to it being done in South Africa, and very limited reference to such an application on the internet. And it happened to be, well, let me first, I think I got my slides mixed up, so I'm going to do this one first. So the requirement was for the Johannesburg Metro building complex, which is downtown in the heart of the CBD of Johannesburg. And the method that was being discussed, there was two methods that was being discussed. One was to erect scaffolding and get somebody to climb up the scaffolding, identify flaws or breaks in the facade, and then record it with a camera. The other way of doing it was by abseiling. So this is it's an accepted methodology around the world, is you get an abseiler, and he goes from the top down the side of the building, inspects it, takes photographs, climbs back up, shifts a couple of meters, goes back down again, and repeats the process until they've covered the entire facade of the building. It's obviously a lot quicker than scaffolding, but I think it can be quite challenging, not to mention the immense risks involved with personal safety. And then, how accurate or how much or how long is it going to take to actually cover every square centimeter of the facade? So to give you an idea of the scope of the project, those are the number of facades that had to be recorded. So every facade of the entire complex, and if I can just point there, whoops. So that building there is a 14-story, we call it a 15-story building, and it's got two facades on either side that had to be inspected, plus the north-facing facade. That was the tallest and most challenging part of the project. And then what the client wanted, he wanted 3 views. They wanted 3 views of each panel. And the view had to be sort of looking down, so you could look at the top of the sill as head on, and then looking slightly up. So again, how do you capture that data? So going back to the solution model, I now had to, because I do not have an ROC, how am I going to operate in downtown Johannesburg? So I had to approach one of the ROC holders and subcontract them to come and do the actual data capturing. So the actual data capturing was a small part of the entire project if you look at all the components. And by far the largest part of this project was the actual post-data capture, the processing and the preparation of a report and handling literally thousands of photographs, and I'll get on to the stats. So the ROC holder that could do the job for me, I was now limited to the technology that they had available, which would allow them to legally operate in the Johannesburg CBD. So all we had at our disposal was an Inspire 1. There was a Matrice 600 Pro available, but it hadn't been RLA'd yet, and they were still waiting for that drone to be RLA'd. And we had a choice between a ZenMoose X3 and a ZenMoose X5. So we sat and went through the scope of the project, and considering the flying time of the Inspire, looking at maximum 14 minutes on a battery. The ROC operator had 19 batteries. I took my additional 4 batteries. So we had 22 batteries on a day to take photographs of every square centimeter of the facade. And we spent quite a lot of time looking at the practicalities of flying, taking a photo, flying, taking a photo, and so on and so on. So eventually what we decided we'll do is we're going to set the camera to 4K, and we're just going to fly as fast as we, well, not as fast as we can, but at a relatively steady pace, and just run video and basically paint the entire facade with video. So we'd first fly, the first flight would run across the facade with the camera facing down, then we'd go down, put the camera straight, fly across again, go down, tilt it up 30 degrees, and then fly again. And that's how we flew around this entire complex over a 6-day period. So being an Inspire 1, we had quite a number of challenges to deal with. I hope this is going to play. No, it's not. We did complete the project as in flying and capturing the video. And initially the idea was to take the video, open it up in QuickTime. So now if you're running a video at 4K and it's shooting 25 frames per second, so within a meter, you probably got sort of 75 to 100 frames covering the same panel. So initially, when I started processing, I used QuickTime. I opened with QuickTime. You can go frame by frame, and then you can actually say edit and copy and extract a frame out of QuickTime. And then if that is just one facade, it was like, this is going to take me for absolute ever. And I had to sit and do some research, and finally I make extensive use of Photoshop, and I learned that I could actually import that video file into Photoshop, and there's a function in Photoshop to extract the images, and you can actually go and say extract every 5th image or every 10th image or every 25th image. You can actually specify, and then Photoshop will play the whole video and it'll go and extract all those images. We're back there. Okay, so I wanted to just show you the process of capturing. Thank you. So we had quite a couple of challenges. You don't need volume for this. The Inspire does not have obstacle detect and avoid. So if you flew too close to the facade, it would actually fly into the facade and you'd come crashing down. I'm happy to report there were a couple of hair-raising moments, but in the 132 odd flights I think we did over the 6-day period, we used the same drone, and we didn't even nick a propeller. We had a lot of turbulence, particularly inside the buildings that we had to deal with. And I think by the end of the 6 days, I noticed a few more grey hairs on the pilot's grey hairs on the pilot. As you could see from that video, it was a dual-person operation. So we had a pilot who focused, and when I say focused, the concentration was intent, worrying about keeping the drone at a distance, a fair distance from the facade, but not flying into the facade. And the second guy basically handled the camera. And I stood breathing over their shoulders every second of the way. And I think after that project, I think they also hated me somewhat. So this is an idea, just one of the flights. So we had to do this facade over here. So it's just going up, flying down. And as he's flying down, he's tilting the camera so that you're getting we're actually capturing the three different views in the same flight. And this was the tallest part of the building, the north-facing facade with 14 stories. And then this is going up on the southern side again to give you an idea of what it looks like up there. If you had vertigo, it's, we actually got to the top of the roof because we tried to do an aerial survey of the area. There you can see we could record sort of chips out of the facade. We could record specific, I mean, that was very obvious, the kind of damage that you were getting there. And that's it. So the idea was to provide or deliver something to the client that would allow them to basically run along the facade, and at any point in time, if there was some kind of damage on the facade, to be able to reference that and go and find that image. So we had, for every facade, we had to build a grid like that. We had a numbering system, and then the numbering system actually referred to the individual set of images. So every grid or every block had 3 images. So you can imagine how many images there were. So just an example of what a panel looked like. This is one panel of 3 windows, looking from the top, looking dead on, and then sort of slightly looking up for them to inspect, to try and inspect every part of that facade. So some stats, the total files generated in images was 9,862. We captured a total of 114 gigabytes of data. Sorry, that is wrong. It took 6 days we had to go back for 2 extra days, and then intensive data processing over a 2-week period. Just an example of from a discussion to looking for a solution to a problem to actually eventually delivering something that helped the client. So that was number 1. Number 2 is spontaneous combustion detection. This was a very interesting project. Again, it was one of the major coal mines that actually approached the same ROC holder that helped me with the Joburg Metro job. And they had a problem. They had a 300-hectare area that had known spontaneous combustion, so it's an underground coal mine, and they needed to detect where these spots were. So again, we used the DJI Inspire 1. I rented out the Zenmus XT camera. We used FLIR tools extensively again for post-processing, post-data capture processing, and I used Pix4D in a different way, and I'll go into that as well. So just what exactly is spontaneous combustion? And forgive me, I'm going to read this because there's no ways I can remember this. Spontaneous combustion or spontaneous ignition is a type of combustion which occurs by self-heating, increase in temperature due to exothermic internal reactions, Jesus, big words for this time of the afternoon, followed by thermal runaway, self-heating with rapidly accelerates to high temperatures, and finally auto-ignition. This is very prevalent in coal mines throughout the world. It's something that the coal mine industry has to deal with as part of their standard operating procedures. It's particularly prevalent with freshly mined coal, which consumes oxygen more rapidly than weathered coal, and freshly mined coal self-heats to a greater extent than weathered coal. Spontaneous combustion is prevalent, as I said, in both underground mining and surface mining, and includes stockpiled coal where a lot of combustion happens. So the area was that area there, 300 hectares, as I said. 5 minutes already. Wow. Okay, let me try and go quickly. There was a known burning point which we used as a reference. And what was quite interesting is we started quite early in the morning. It was August time frame, so it was incredibly cold. It's not, oh, there it's playing. It's not playing on here. So what you're looking at here is that's where it's burning. There you can see the temperature of the actual excavator. And the way that they handle this is that if they find the point of burning and they actually excavate it out, and then they have a water tanker that drives over it and tries to extinguish it. We then flew over the area and we captured radiometric JPEG images. That is a screenshot of FLIR tools. So using that as a reference, so the surface temperature was about 58 degrees. The surrounding temperature was between 5 and 7 degrees, so that was a known hotspot. And the method, there's different ways of measuring. You can do spot metering, you can do area metering, you can do circular metering. And what that would give you, depending on the size that you mark, bearing in mind that every pixel has got temperature information, it'll actually give you the highest point, the lowest point, and the average temperature. So, your ground temperature was an average 7 degrees, 10 degrees, and then you get a hot spot of 50, 60, 70 degrees. You know that that is a hot spot. We took a photograph, and because you took a photograph, it was actually then the GPS coordinates was embedded in the image. We used Pix4D purely to pinpoint every photograph that we took, and that is the area that we mapped. We then, where we found an image that, or a spot that conformed to the requirements, we went onto Google Earth and we created a marker, and at the end of the day, we sent the KMZ file to the client together with an online folder, and he could then go and pinpoint those, open the image and see the temperatures, and it helped them quite tremendously. 1,282 images, 2.8 gigabytes of data, bearing in mind it's only 640 by 5112 megapixels, a total of 15 thermal reports, 6 hours and 7 days of data processing. And then just lastly, what does spontaneous combustion look like? So this was a known stockpile that was burning. You can see the smoke coming out of there. We flew over with the thermal camera, and they were actually missing the spot. We had to speak to the drivers and say, you're right on the edge, you actually have to go a little bit more to the left because you can't actually see it. This stockpile is burning. You can't, it's not very noticeable. That is the epicenter of the burn. And the way we detected was we flew over it, we actually, so there you can see the hotspot is in excess of 150 degrees Celsius. And when you fly over, you look carefully, you'll actually see the smoke coming out of the top of the coal mine, the coal dump. So we saw the smoke, and to confirm that, we then flew with the thermal camera, and we measured. The fire was actually coming right to the top of the stockpile. And again, that is where the fire is. You can't see it with the naked eye, and that's what thermal technology does to show you, to pinpoint exactly where that fire was. So they were able to extinguish that. In future, what we would use is the Matrice 200 and definitely the new Zenmus XT2. So it would save that dual flight. It would give you both your RGB video and your thermal imagery. Sorry, I can't forget. I think I've got to finish off. Sorry. If I had time, I was going to show the video of the XT2, but I think by now you've all seen that, and that concludes my presentation. Thank you very much.